Hello, high school astronomy students. Hope this video finds you well. We are going to be going over how to tell time with the sun today. Before we start, though, I do want to just go over the week, just kind of give you an overview of what's in our sky. Hopefully, you've been taking advantage going outside of these beautiful evenings we've been having. Looking straight up in the evening sky, or the 9 p.m. evening sky, you should find yourself Leo the Lion, dominating the sky as he should because it is springtime. So he of course, is the icon for the spring season. Orion slowly fading off there in the western sky as he should be because he's the winter, icon for the winter. And it's no longer winter, it's leaving. So it should be setting in the west. However, over by Orion, the last couple weeks of Venus is in our sky. That big beam, that bright beaming light over in the western sky. Make sure to take a look at that for the last couple weeks before she, with Orion, sets and can't be seen any longer in the evening sky. They'll all set together with the sun. And last but not least, the best time of year to view Ursa Major or the Big Dipper. So be looking out for that above Leo, or if you're looking north, it should be spilling out its water from the Dipper. That's why it's raining so much, right? But with that, oh, and of course, Hydra, the water snake, very long underneath Leo. All right, so with that, we ended last lesson with looking at a sky that looked similar to this. We had the sun in the sky, just a little bit a ways beyond the median line, and we talked about the fact that if we can use the skills we learned of measuring constellations, we can measure the sun and help with time. And that's what I first need to get across to you guys is make sure you realize time. We have this weird view of time. It's a correct view where, time is what makes us late or early to something. Time is when I have to be at work and I work, X hours, and then I go home and I get paid a certain amount depending on those time. So we have this concept of time of being late and early and just a schedule. Well, time really isn't a schedule. Time is really the measurement of the position of the sun. It's the solar position is what time really is. And hopefully through this lesson you'll get this concept of how time came to be and things like that. So to start though, we're going to start at noon. And so I'm going to back up time here, and you can see the sun is now at noon. The sun is in the middle portion of the sky. It's directly south, and it's as highest it will be for the day. Now when I say noon, that might have confused a few of you, because if you've been looking over here at the time, you'll realize it is not 12 o'clock. But that's what we've learned, right? We've learned that 12 o'clock occurs, or noon occurs at 12 o'clock. That's sort of what we've learned. But it's not true. Noon, by definition, is just when is the sun in the middle and highest in the sky. That's the definition of noon. It doesn't necessarily mean it happens at 12. And the reason for that is because of how the Earth rotates and how time works. Really, let me lead into this by introducing to you time zones. So if you take a look at this world map, all the colors represents which time zone these countries follow, or which what they lie in. All right, now we're going to go into how crazy the time zones look, but I want to go back to I'm going to take this super simple and just take a look at what time zones should look like. And when we do that, this is what they should look like. Because time zones are an astronomical thing. It's a way to adjust our clocks to keep track of solar noon. When is the sun highest in the sky for where I live? All right, let me give you an example. So if I use this Google Maps here, and let's pretend in this example you are the sun. So you're the sun, you're looking down on the earth here, and right now, the portion right under you, right where my mouse cursor is, that portion right there, that's the portion that's right under you. And so all of these people right under you, they're getting noon. The sun is the highest it'll be for them. But notice for Tulsa, yeah, it's not highest for us yet. It's not directly under the sun, and even worse for California and the West Coast. But the East Coast over here, the sun is directly over them. So for them, it's noon. But then as the Earth rotates underneath the sun, you'll notice, and it rotates at 1,000 miles an hour, even though it doesn't appear that fast. But as you can see, as the Earth rotates, eventually Tulsa then falls into that section that is right below the sun. So now it's noon for everybody here. And the Earth continues to rotate under the sun, and you can see now it's over in the mountainous areas. These guys are now getting noon. And then California and the West Coast are getting noon, and it continues to do that. So if you understand this simple concept of the Earth rotating under the sun, and thus the sun being directly over different portions of the Earth every second, it's over a different portion. But we divide it into hour sections. Then time zones shouldn't be that hard to grasp onto. These are just sections in which the sun is over this section, and then the sun is over this section, and then the sun is over this section. And that's where time zones, the concept of time zones start. And that just concept of Earth rotating under the sun. Now, how did us humans sort of invent the time zone? Where did we start? What are the steps? Well, we started in Greenwich, England. So if we go over here to the UK, Greenwich is right there. And Greenwich is where we decided to put the prime meridian of our planet. So if we draw a line from the North Pole through Greenwich, England, and go all the way to the South Pole, that is 0 degrees east and west, the prime meridian. So this line is very important to the start of time, if you will. We could say this is where time started. Now with that, we go 30 minutes to east, 30 minutes to the west, and that creates a 1 hour section that we're going to call the Greenwich Mean Time. This is the start of the time zones. This is where we consider them to start. All right, so that's where you get it. Now, if we talk about this concept of noon, who in this section is experiencing noon at exactly 12 o'clock? Well, that's the people on the dotted line. The people in Greenwich, the people down here in Africa, and down here in Europe too. Everybody on this dotted line is getting that noon at 12 o'clock. But if you live over here east of that, then you're actually getting noon earlier because the sun is over your portion of the land before it gets to Greenwich. So you actually get noon at 11:30. Or people on the west side over here are getting noon later, about 30 minutes later. So their noon occurs at 12:30. So beware that noon is not specifically 12 o'clock. Noon is just wherever the sun is at its highest point for where you live. So let's talk about where we live. How do time zones sort of work in the U.S. here? So you can see the yellow lines again represent the astronomical time zone, where they should be, and the colors on the map represent where they are. So you can see the Eastern time zone bleeds a little too far west into our time zone, but that's okay. You can see why. You can see that the Eastern time zone would divide the state, for example, like Florida, in half. Half of Florida would be Eastern time, the other half would be Central time, and that can be very confusing for a lot of businesses and just everyday sort of running of a state, of our government. So they've decided that they were going to make lines based on state lines or rivers or geological lines, stuff like that, and that's why our time zones don't really line up perfectly with the astronomical time zone. But the concept is still the same. If we go into our section here, the central time zone, here is the very central of the central time zone, and thus everybody living on that dotted line, noon will occur at noon, or at 12. Noon will occur at 12 if they live on this line. Okay, it'll be earlier if you live closer to this side. It'll be later if you live closer to this side. And I think you know where this is going. That's where Oklahoma is. Oklahoma is closer to the west side of our time zone. And because of that, because Tulsa is located right there, you'll see, look how close we are to the 12:30 or the end of our time zone astronomically. Now, we're kind of in the center of the entire time zone, but that's because this west side of our time zone is way into the mountain, astronomically, mountain time. But you can see here in Tulsa, we're just a little bit away from that 12:30 time. And so our noon should occur, just about 25 minutes into the hour before the 30 minutes. And that's exactly what we saw. That's exactly what we saw. Actually, here's some data of when solar noon is going to occur on several days of this week and in the past weeks. So you can see 125, 25, 23, 22, 21. Now it's going to slowly change as the seasons change. That's another topic for another time. But for the main point is you'll notice that noon is always occurring 20, 25, sometimes even 30 minutes into the hour. It will not happen at 12 here in Tulsa because we don't live on that dotted line. I do want to remind you why it's 1:22 and not 12:22, but that's daylight savings, that wonderful non-astronomical event that we do every year. Wish it was going away, but since it's not, it's just something we deal with. So solar noon, the time the sun is at its highest point in our day, is actually 1:22. And again, 22 minutes because of how far we're into our time zone. So let me just take one last look at one of my favorite examples to show when I'm looking at this is China. China has decreed, their government has decreed that everybody in China will be on the same time zone regardless of where you live. And so you can see where this could lead into some really interesting things. For example, let's say you lived on the east side of the country, maybe over here in this little blip. Let's say your sun rose at 6 a.m. All right, so let's say, for example, the sun rose at 6 a.m. in this area. Well, think about it. This is 1, 2, 3, 4 hours later, the sun will actually rise on this part. But the clocks are the same. So 6 a.m. sunrise here, 7, 8, 9, 10 a.m. sunrise here. So it's already 10 a.m., 10 in the morning. We'd be in like second period and the sun is just rising on this side of the country. So you can see that that would lead to just a different way of living, different way of working. They just have to sort of get used to it. And you can see many examples throughout the world of just how our time zones are kind of skirting around. One of my other favorites to point out is England itself, how England is in this beautiful green in the right time zone, and then the rest of Europe is sort of in this brown, not following England. I just thought that was really nice, even though these are technically in the same exact time zone. So just fun things like that you see with our time zones on our world. All right, so this now leads us into how do we use this concept, this idea of the sun over us, our solar noon, how do we use that to tell time? Well, let's do that. All right, so the way I'm going to show it to you is I'm going to remind you of our angles and how we can measure. So here's the sun. The sun is on the meridian line. And because it's there, we know it's noon. Now, it's 12:30, but remember, we know why now it's not exactly 12. And why is it 12:30 and not 12:22 like it was before? Because I've also moved the date. It's actually spring, March 21st. I wanted to start on the first day of spring. You will see why in just a second. But let's first start, of course, define our meridian line. Let's remember that that's that line that draws from the south to the north, that imaginary line we draw to sort of split our sky into an east side and a west side. When the sun is on that line, it's noon. All right, so we define that. Now, I've already told you we're back to March 21st, the first day of spring. We could also do this on September 21st, being the first day of fall. It would look the same. So this is the spring-fall example, the equinox of measuring the sun. All right, so let's say an hour passes. What would the sun appear to do? Well, we know the earth would turn. And so the sun would, an hour later, look to be right there. All right, now if we take a measurement, now here in the planetarium program, I can actually click and actually get an angular separation and notice that the angle separation is about 15 degrees. Okay, the angular separation is about 15 degrees. Perfect. 15 degrees, the sun has moved 15 degrees. Now, why 15? Well, we like 15 because we can measure it. Remember that our measurement we used in telling date, we used our rock and roll fingers in the sky to equal 15 degrees. In the planetarium is a peace sign. Here on your screen, use whatever you can. But each ruler that you use is 15 degrees. It equaled 15 days in our last unit, but here, if we remember, the Earth rotates 360 degrees in 24 hours, which equates to 15 degrees an hour. Perfect. We already know, we already have practiced the way to measure degrees in the sky using our rock and roll fingers. We can use it again, this time to give us 1 hour of time. So we know that the sun has moved 1 hour because it's moved 15 degrees away from the meridian line. And so, since it's moved that 1 hour past it, we call this 1 p.m. If you've ever wondered why do we call this 1 p.m., well, it's very simple. It's 1 hour post-meridian. All right, again, this line in the middle of the sky, that imaginary line we draw, is called the meridian line. And if we are past it, post-meridian. And because we're 1 hour past meridian, we call it 1 p.m. or 1 hour post-meridian. Now, of course, the Earth continues to rotate and goes another 15 degrees, which means we can take our hands, measure a second 15-degree unit, or now 30 degrees beyond the line. So we know that's 2 p.m. or 2 hours post-meridian. Then another 15 degrees, the Earth rotates, giving us another hour of time. We can then measure a third ruler across the sky, giving it 3 p.m. or 3 hours post-meridian. And so you're seeing the concept here. We continue to do this all the way until the sun sets. And so you can measure four rulers to get 4 p.m., 5 p.m., 6 p.m., and the sun starts to set at 6 p.m. in the spring. All right. Now, we know that the Earth continues to rotate even through the night. Now, it gets harder to measure time once the sun is set until you learn how to tell time with the stars and the moon, which we'll do another time. But what I wanted to point out is what happens when the sun is directly behind us. So the sun has started here in front of us at noon, goes all the way around in 12 hours, and now it's on that side. Well, now I get to introduce you to the term anti-meridian. Right? Anti-meridian is the opposite of the meridian. So if this line in front of us we always consider the meridian, then the opposite of that is the anti-meridian. The meridian we don't see, the meridian that's on the other side of the planet. And I think you already see where this is going. If it goes 1 hour, past the anti-meridian, what do we call it? 1 a.m. That's where a.m. comes from. We're now 1 hour past the anti-meridian. All right, so the Earth continues to rotate, bringing the sun around until it is 6 a.m. 6 hours past anti-meridian, we start to see the sun again. And then of course, 7 a.m., 8, 9, 10, 11, and when we get back to the 12 p.m., it resets and starts again till 1 p.m. and 2 p.m. Now, I've been using this term that it's 1 p.m., it's 2 p.m. What I mean by that, though, is that the sun is in the 2 p.m. position. Remember, you still have to make adjustments. So sure, we take our 2 hands and we measure that. Okay, it's 2 hands away from the meridian, so it's 2 p.m. Well, that means the sun's in the 2 p.m. position. But what do our clocks physically say? 2:30. And that's because we have to make those adjustments. You have to make those adjustments based on where we live. And because we live in Tulsa, it's going to be 20, 25, 30 minutes after the hour, depending on what season we're in. So we got to think of these like 1 p.m., 2 p.m. labels as positions, not physical clock readings. Now, it'd be nice if we lived right on the dotted line of a time zone. Then we could use it as a physical clock reading. But you have to make those adjustments. So sure, the sun's in the 2 p.m. position, but then you have to, for at least Tulsa, I like to add 25 minutes to it to get a more accurate measurement of time. All right. So hopefully through that, you get this concept of telling time with the sun. Now, the thing I have to warn you about here, all right, I have to warn you about the fact that we have other seasons. For example, let's go to the summer. In the summer, because the Earth's tilted, our northern hemisphere is tilted more towards the sun's going to appear higher in the sky. So it's not going to follow this perfect line that we've sort of learned this from. All right, so you can see that the sun isn't down here in the spring fall, it's a little higher, but it still works. You can see that if we extended this red line through the sun, it would go through the 1 p.m. position. And again, it would go through the 2 p.m. position. And then again, it'd go through the 3 p.m. position. So it still works, but you have to learn that you have to measure it a little bit higher than you would normally do so. All right, so for example, if I did measure the angular separations, you can see that it is still 45 degrees. Oh, I messed that up there. Let me try it one more time. It is still 45 degrees from that midline. All right. Now, what I want to point out here in the summer is, I think you all realize that during the summer that the days are long. The sun seems to set much later in the day. Well, let's find out why. Here's 3 p.m. There's 4 p.m. There's 5 p.m. There's 6 p.m. But notice that 6 p.m. in the fall and spring, it's already set. It would have been on the horizon. But because the sun is higher, we have another hour still. Now it's 7 p.m. and it's just now heading for the horizon. And by 8, it has finally gone down. All right, then it comes around and all of a sudden it rises super early. It rises at 5 a.m. Then it gets to 6, 7, 8, 9, 10, 11, and back to 12. All right, so you can see the path that the sun takes in the summer is much higher, and you have to make those adjustments. It takes a little practice, but you have to make those adjustments as you measure the sun. Then, of course, we have the winter hours. When we get into the winter time, the sun is very low. This is why winter gets cold. The lower sun can't provide much heat. But you'll notice that the system is the same. If I advance an hour, notice how the red line goes right through the position of 1 p.m., just a little further because the sun's a little lower. Now notice when now the sun goes down. 4 p.m. already setting. Much earlier. Our winter days are short, and our nights already by 5 p.m. the sun has set. 6, 7, 8, all the way around. Notice when we get to 6 a.m., still not up yet. 7 a.m., just not up yet. 8 a.m., it's finally up. And so our winter sun takes a lower route. Same concept. We're still measuring the sun, how many degrees past the antemeridian or postmeridian is, but it got to just adjust for the seasons. All right, but the concept is the same, and the best one to always use is the spring fall. That's how it's sort of the medium, the middle of the line. So get out there, measure the sun, test yourself. Get out there, find your meridian line. That's, again, remember, you got to find south wherever you live. Find south. Pick just a random time of the day. You'll have your clock. You'll have your phone. You can tell what time it is. Really, it's just checking. Can you prove it is the time that you do this? Go outside. How many hands, how many rulers is it away from the meridian line? Practice yourself and say, how close can I get to predicting the actual time? Remember, 2 p.m. position is not the same as the clock reading 2:30. You got to make that adjustment for Tulsa. Add about 25 minutes to your measurement. So hopefully you got a lot out of that. It's one of my favorite things to teach. I really love this concept of how to tell time. But use this information, get out there and practice it and have some fun. I'll be back next time with how to then take this and tell time with the moon. Something to do at night if the moon happens to be up. So I hope you guys continue to have a great rest of the year. Stay safe. See you next time.